Yes. Hi everyone. I am SS KIRAN. I am dealing course is electromagnetic waves and transmission lines. In this course, I would like to discuss about Coulomb's law in electrostatics. The course name is electromagnetic electromagnetic waves electromagnetic waves and transmission lines. In this course, I would like to discuss about Coulomb's law. Okay, this is electromagnetic waves and transmission lines. The short form of this course is EMWTL. EMWTL. The topic name is Coulomb's law. The topic name is Coulomb's law. Right. Now, before going to this Coulomb's law, let us consider 2-point charges. This is one Q1. This is another point charge treated as a Q2. Okay, this is Q1. This is Q2. Now, the line joining them between these 2 points. Okay, this is 2 points, the line joining them. Okay, so this distance is of these 2 points treated as a R1. If it is 1 and 2, this can be treated as a R1, 2. At the same time, consider one horizon point also. Okay, now you have to join these 2 points, horizon point and another point. This is also another point. You have to extend these lines. Understand? Okay. Now, Coulomb's law states that now the definition is Coulomb's law states that the force between the force between 2-point charges Q1 and Q2, 2-point charges, 2-point charges Q1 and Q2 is, there is 3 important considerations. One is the along the line, joining them, the line joining them. The second point, okay, the second point, directly proportional to this force, directly proportional to the product of Q1 and Q2 charges. The force is directly proportional, listen carefully, proportional to the product of Q1 and Q2 of the charges. Okay. The next one is, this is treated as horizon. The next one is inversely proportional. What? The force is inversely proportional to the square of the distance. This is called distance. Denoted with R, proportional to the square of the distance. Square of the distance R between them. So this is the Coulombs law. Again, I will repeat you. Coulombs law states that the force treated as a F between 2 point charges Q1 and Q2 is along the line joining them directly proportional to the product of two charges Q1 and Q2, inversely proportional to the square of the distance R between them. Now, I will express it in mathematical form one by one. Okay. Now, the first one is force directly proportional to the product of two charges Q1 and Q2. The second mathematical expression is F inversely proportional to the square of the distance, that is called 1 by R square. Now express it in mathematical approach. Express it mathematically. I will note down as mathematically. F proportional to the F is proportional to the Q1 Q2 by R square. Okay. Now just we can remove this proportionality with the help of K. Okay. Now K is the proportionality constant. Okay. Now this can be expressed as F is equal to K into Q1 Q2 by R square. Okay, now take as a box. This is very, very important expression. Okay, this is very, very important expression. Right. F equal to K into Q1 Q2 by R square. Now K can be written as 1 by 4 pi into epsilon naught. Epsilon is a permittivity of free space. Units is farad per meter. Okay. Now the epsilon naught is a free space permittivity of the free space. You may call any type. So 8.854 into 10 to the power of minus 12. Now pi. Okay, now the final K value, doing some mathematical calculation, 9 into 10 to the power of 9 meter per farad. The permittivity units is farad per meter. Okay, this is the Boltzmann constant value. Now final force expression can be written as F equal to Q1 Q2 by 4 pi into epsilon naught into R square. So this is the final expression. I will go with one box. Okay, this is the final expression. Now, if point charges Q1 and Q2 are located at points having some position vectors, is treated as this is R1, okay, and this is R2, then the force of F12 on Q2 due to Q1. Okay, now you can write a little bit extension of this one. This is force, actually F21. This is force on F12. Okay, fine. Now, based on this vectors and direction, force expression is little bit modified with the help of direction vector and unit vector. Now, this F1 and F2 equal to Q1 product with Q2 4 pi epsilon naught R square with the direction is unit vector A R, you can write in suffix A R12. Okay, this is the unit vector. Now the final expression with the direction is F12 equal to Q1 Q2 by 4 pi epsilon naught into R square. Now AR12 is a unit vector. You may write like this. Little bit mathematical part. Here I will extend this one. AR12. You can write R12 bar by modulus of R12. Okay. Now this R12 is, you can write as a distance, right? Now this is R12 bar by, this is only R. Okay. Modulation. Mod. Okay. Now finally this expression is substitute in equation 1. Now F12 equal to Q1 Q2 by 4 pi epsilon naught. If it is distance R, this is distance R is denoted with R12. Now R is replaced with R12. R12. This is also, you can write R12. Now in this unit vector A bar, AR12 bar replaced with R12 bar. This R12 bar means some vector. Okay, you have to calculate distance. Now finally this R12, this actually 4 pi naught R12 square by this is R12. Okay. Now this R12 square into R12, you may write R12 whole cube. Okay. Now the final expression for the force with the help of distance Q1 Q2 by 4 pi epsilon naught into R12 whole cube. So this is R12 bar. Okay. Fine. So this is the force equation, right? Okay, now I will extend little bit. If you considered more number of points, Q1, Q2, Q3, Q4, you can simplify this expression with the help of following equation. Give me some time. I will take another slide. So this can be treated as a JPEG. Then I will go with once first I will do save. Then I will go with the JPEG. So next to save, delete, then control S. Now this force expression, little bit extended to with the help of points R2 minus R1. Now finally F12 equal to Q1 Q2 by 4 pi epsilon naught into R2 bar minus R1 bar. So extend this one. Now R2 bar minus R1 bar with mod. So this is cube. Okay. So you may extend little bit F12 equal to minus F21. This discussion may helpful for the problematic part. Okay. Now, if it is unit vector R12 bar equal to minus A R21 bar. Okay. Anyway, so if I consider different points located Q1, Q2, so on Qn, this force expression will be extended like following one. So finally, this is very, very important expression. F12 equal to Q. One point is fixed, another point is vary, then Q into Q1 R minus R1. This is the point 1 by 4 pi epsilon naught into, you can write R minus R1 bar with mod Q plus another point with respect to Q, Q1, Q2, R minus R2 bar. You have to write these directions also, unless it is difficult to understand in problematic side. 4 pi epsilon naught into R bar minus R2. This is mod. Then so on. I will take nth one, nth point, Q into Qn, R bar minus Rn bar with brackets by 4 pi into epsilon naught into R bar minus Rn bar with 3. Okay. So if I write in some summation format, so I will write down the final format. F12 equal to Q by 4 pi epsilon naught into sigma K equal to 1 to capital N. This is QK R bar minus, this is RK bar by modulus of R. This is bar and this is modulus of Q. Okay, fine. Now I will do save now. Shortly, I will discuss about electric field intensity also. Okay, thank you so much. Keep watching. Next video, I will discuss about electric field strength or electric field intensity. Thank you.